All right, so we're still in chapter 4. Take a look at the PowerPoint. I believe we were around here on while loops. We know what a while loop is, and now we know what a sentinel value is. Sentinel value is a piece of data that's treated differently. Enter a series of test scores, or -1 to exit. Enter a series of temperatures, or -99999 to quit. So you see what it is. You're giving them a chance to enter something. You're offering them the option to quit, and you're doing them both at the same time. Otherwise, you have to do enter your test score, whatever. Do you wish to add another one? Yes, no. And you have to answer 2 questions for every piece of data. So that's what's known as a user query termination. So our 3 kinds of loops are counting loops, user query. Do you wish to continue? Or do you wish, YN, and why did my brain just freeze? Sentinel value. Enter score, or -999 to exit. That kind of thing. So along with the while loop, don't know why we need the recording down here, we have the do loop. Did we talk about the do loop? Alrighty. Do loop is the same as a while loop, except it's got one key difference. If you write a while loop, it looks kind of like this. Your test goes up at the top. While condition do stuff, right? That's its most basic. And if condition is true, just like an if statement, it comes in here and does some stuff. Then after the stuff is done, it comes in and checks the condition again. Now something had either better change that condition, or there better be a break statement, or else it's going to be an infinite loop. But that's the way that one works. So if condition is false to begin with, it won't even go into that loop. So if we had this, x is equal to 10, while x is less than 5, print x, print line x, I'm not going to type the whole thing, and then x minus minus, right? That's kind of dumb. So while x is greater than or equal to 0 and x is less than or equal to 5. I kind of like that one. And then we're going to increment x each time. Okay, so if we start off x at 0, what's it going to print? Well, is x greater than or equal to 0 and less than 5? It sure is. So it would print 0. It's going to add 1 to x. Is 1 greater than 0 or less than 5? Sure is. So it's going to print a 1. 2 greater than 0 or less than 5? It sure is. Is 3 greater than 0 or less than 5? It sure is. Is 4 greater than 0 or less than 5? It sure is. Is 5 greater than 0 and less than or equal to 5? It sure is. Why did I type in 5 there? Okay, already. And then lastly, it gets incremented one more time where it's 6. Is 6 greater than or equal to 0? Yes. Is it less than or equal to 5? No. And since this is an and, it requires both sides to be true. So it stops there. So that's what it would print out if x was equal to 0. And if you set it equal to higher, it would start counting at 3. 3, 4, and 5. If you set it equal to 5, it would print 5 and quit. What if you set it equal to 10? While x is greater than or equal to 0, that's true, and x is less than or equal to 5, is that true? Thumbs up, thumbs down. If we set x equal to 10 here, that's certainly true. X is greater than 0, but is this half of the and true? I see some heads shaking no. No, that is not true. So it doesn't even go in here at all. So if x is equal to 10, it skips this code entirely, just like it was a while loop. So if x was initialized to 0, the above is what we would get. If x was initialized to 10, or any number larger than 5, we would get no output at all. Now we're going to rewrite this as a do loop. X is equal to 0. Maybe I'll start it at 3 or something so we don't have to count as much. But anyways, do some stuff. Print x, x plus plus, while, I'm going to make the if condition easier, while x is less than or equal to 5. And we didn't have this in Python, but the C-based languages such as Java have do-while loops. So this is what's known as a pretest. The test comes before the block of code. This is known as post-test, the do loop, because the condition, the check, comes after the block of code. That means that it always goes in here. And we'll prove that to ourselves. Up here, when x was equal to 10, it didn't go into this loop. It didn't go into this body at all. Okay, so it's equal to 0. I'm going to lower the condition down to 3. Is x less? Do this. Print 0. Good enough. Add 1 to x. Is x still less than or equal to 3? It is. Print another x. Add 1 to x, so x now equals 2. Is 2 greater than or less than 3? Sure is. Come back up here. Print x, which was 2. Add 1 more to it, so x is now 3. Is 3 less than or equal to 3? Sure is. Then it adds 1 to x. X is now 4. Comes up here, except it doesn't. Because once it increased to 4, this while was no longer valid. 4 is not less than 3. So it printed out 0, 1, 2, and 3. What if we set x equal to 10 and we have the same code? It says do this stuff. All right, I'm going to print out x. So it prints 10. Then it adds 1 to x. X is now 11. Is this condition true now if x is 11? No, it's not. So that's all it does, but it did do one thing. It did print it. Whereas up here, if we'd set x equal to 10, it didn't do anything. So that's the difference between the two. Use a do loop if the block must be executed at least once, because the test comes after the block. You know the block's going to be executed once. Use a while loop if it's okay if the block is not executed. Now honestly, you could write a while loop to do anything. You could use a while loop to do a do loop or a for loop or whatever. It just the logic becomes more complicated in order to get it to work. And I could prove it. I could come up here. You know, we could do while true and then have a if something break. You know, something like that. I don't think I need to rewrite that. Oh, why not? We're going to take this code and replace it with a while loop, and then I'm just going to delete it. So while true, print x, x equals x plus 1, if x, if not, x greater than or equal to 3, break. There. That does the same thing.
That's not a post-test anymore, is it?
It's not a post-test anymore, but it is a post-test. Because the real meat of the test comes here. This is just a garbage test. You know it's true.
Will it still parse through the number, the original number you input into it?
Right, right. If we set this equal to 0, it would still print 0, 1, 2, and 3. But there may be a slight difference, but it's close to being the same thing. Tell me your concern, because there's something that's bugging me about it. I think I've done something wrong.
Well, I was just curious. Like, the other way just seemed easy.
Exactly. It's easier. Right. So the do loop is a nice, succinct syntax, and I think the languages like Python that don't have it should have it. But what do I know? I didn't, make a language like Python that millions of people use. The same is true of for loops when we get to for loops. The for loop syntax is really nice and clean, and you can implement it with a while loop if you want. So anyways, so use a do loop if the block must be executed at least once. Use a while loop if it's okay if the block is not executed. We're going to add a third condition up here. These are like our rules for loop types. These are rules 2 and 3, and then once we hit for loops, that's going to be our rule 1. So when do you use a do loop? Well, we already talked about it. But for example, you could display a menu. Or you could run a block of code, and then your last question is, do you wish to repeat? And so you repeat, as long as while repeat is equal to yes. Could you have done it the other way with a while loop? Yeah, you probably could have. It gets rid of the need for a priming read. And did I talk about priming reads? That a familiar phrase or not? Maybe? Do it real quick. A priming read looks like this. Print, enter a value, or -1 to quit. You get that value. X is equal to scanner.nextInt. Then while X is not equal to -1, you do some code. Then you ask them again. Print, enter a value, or -1 to quit. And even if you took this off, enter that value off, it would work the same way. Enter value or -1 to quit, and then you read it in again, if sc.nextInt, like that. So this is called a priming read because it gets a piece of data to start messing with in the while loop. You do the block of the while loop, and then you get the same data again. I personally do not like priming reads because I don't like the fact that the input statement is repeated twice. I'd rather do it like this, using a break statement. You could probably also do it with a do loop, but I'm not going to think about that. So in this case, you do while true. You just set it up as an infinite loop. You ask them for their input, print, enter a value. You read that value in, x is equal to sc.nextInt. But we tell them, enter a value or -1 to quit. And so if x is equal to our sentinel value, then we break. Else we do some good stuff. Logically, these two things do the exact same thing. I'm going to go back and change this to enter value or -1 to quit so they do exactly the same thing. But this one avoids using the priming read. We don't have that code up here. I ought to be I'll type this in so I get everybody staring at me. But sometimes you just have to do some good old lecturing. Hope that makes sense. Which is better? It's up to you. This one has an extra level of indentation, right? Whereas this one didn't. And this one relies on, break statement, whereas this one didn't. If this one makes total sense to you, use it. I tend to use that one, and so I tend to teach it a lot. But there's always more than one way to do things. Hope that makes sense. So that's a do loop. It's a post-test loop because the condition comes at the end. Proper style dictates putting the while part on the same line as the terminating brace. Let's see if I did that. Yeah, I did. And then you have to put a colon there. Excuse me, a semicolon. Usually using a colon in a loop statement breaks it. If I went up here and if I did while true and then I put a semicolon there, it would never get out of it. It would be an infinite loop with no way out. Same for this one. If I put a colon here, a semicolon there, this is always going to be true. It would repeat this code infinitely. It would never even get to do any of this stuff. Yes, sir?
Will it mess up if it's not on the same line as it? while.
No, it won't. It said proper style. I don't care if the while statement is on its own line. Why not do this, you know? Looks good to me.
It's just like a proper form.
Yeah, just like some people put the curly braces on the line above it. It's just aesthetic or aesthetics. All right, so here's some code that would ask the user for their room dimensions, and it would calculate the floor space. So enter the length. We write in the length. Enter the width. We write in the width. Floor space is length times width. Then are there any more rooms? Yes, no. Response is equal to dot next. And so it keeps repeating as long as they don't type in anything other than yes. Or excuse me, as long as they type in a Y, it's going to keep going. So this is a perfectly valid way of doing it. And this is not a bad way because if you're single values are great if you're entering a single value like a test score, but if you're entering a pair of values or 3 or 4 different values, what are you going to do? Enter the length or -1. They type in something, or enter the height minus, you know. This is good. If you have more than one input per iteration of the loop, it's reasonable to avoid using a sentinel value and instead ask them if they wish to continue. And if you're going to do that, a do loop is a perfect way for it. Why? Because you know you want to execute at least once. You know you want to ask them for the length and the width and print something out. Otherwise, why'd you run the program? So this is a perfect example of using a do loop. You get some input, you print some output, then you ask them, hey, you want to continue? And if they do, that's part of the while, and it repeats it. Oh, this is interesting. They keep accumulating floor space. You enter a length and a width, 2 by 2 is 4. Then you enter another length and a width, 10 by 10, it adds it onto that. So it's now, 100 plus 4 is 104. And only when you quit adding rooms to it does it print it out. That wouldn't be a bad thing to make you type it. I'm in a hurry to reach the for loop. Why is there? Okay. They ought to show the syntax before they start talking about when to use it. Okay. So with the for loop, you can iterate over a series of values. That's what a for loop is really for. You can use a while loop to iterate over a series of values, right? You started off at 10 and you just subtract 1 from it. But for loops are primed and ready. Their entire being is devoted to iterating through a series of values. And so if we're going to do this, say we're going to count all the numbers between 10 and 100 by tens. So let's actually type some code in. For loops are important enough that I'm going to make y'all type in some code. As long as you remember that do loops or post tests, it's probably all that I'm going to ask for on the exam. Start your project up. Go get some coffee while NetBeans loads. Hey, that was pretty fast. Alrighty. New project. Next. September 26. Hey, I wonder what... Have you been putting periods in your project names in Java, or was that just in Python? Huh. Okay. I'm going to play an experiment. This is just... Don't type that.
The class at the bottom,
Yeah?
I found out that you can alter that, so I won't put periods in that.
Oh, I see what's going on. So you modify the class at the bottom to remove that part from it. Okay. Well, I want to see what happens if I left it in there. Does it create a package named CIT1613 in my project? Yeah, it sure does. All right, okay. Anyways, put your name, Joe user, demonstrating loops. Delete that comment. To do code application here. Alrighty. So here's our comment. I don't like that color for comment. I'm going to make my colors brighter. I guess y'all can see them. No, that's awfully faded. Uno momento. We want a loop that will count from 10 to 100 by tens. So we have to have a starting point, right? Int start is equal to 0. That's going to be our counter, our control variable. But I actually want to start it at 10. So I'm going to change that to int start is equal to 10. Then my ending point is 100. So while, I don't like calling it start, I'm just going to call it x. Because it's not going to be a start once we start adding things to it. While x is less than or equal to 10, 100, let's print system.out.println x equals plus an x. And I think I'll put the words while loop colon in there, just to distinguish it from what we're going to do next. And if I stop here, what have I forgotten to do?
Pause. Or you count at the bottom of it, right?
Yeah, not only the, I have to increment x, or else this condition never becomes false. So x plus equals 10, so that we're counting up by tens. And by the way, I haven't been doing this for y'all, but I like adding the comment end main, or the end of the method name, for the second, the penultimate brace, and then end class at the bottom. And that way, once you start running, you know, when you start getting errors like reached end of whatever parsing, it's easier to figure it out. And you could even do end while, you know, like that. If you put a comment on your closing braces, it's easier to figure out what's going on. Do you have to do that? No, I'm going to delete that end while one.
That's a good idea.
I think it's a good idea. When I'm doing professional code, I always do it. Oh, and look at that. Is this telling me that my recording is only getting the upper? Yeah. Oh well, I hope everybody's here. That has to be what it's telling me. All right. Well, I will upload these notes that I took. Read over the notes. I apologize for not getting the entire screen for those of y'all viewing this at home. Let's run it, make sure it works. Hammer and broom. Click the green arrow, and it printed out 10 all the way up to 100. It worked. So if we label what these things are, we have an initialize step. We have a condition check, and then we have an update. So we initialize our control variable, we have a condition that checks it, and then we update it. Those are the three parts. What are cool about for loops is that all three of those are listed in one place. So let's count y now. I'm not going to even declare y before my for loop. For int y is equal to 10, keep running while y is less than or equal to 100, and each time we update, add 10 to y. Y plus equals 10. And now all I need is a print line. System.out.println for loop colon y equals plus y. So I'm going to put a comment before that, a for loop to count 10 to 100 by tens. And this one was actually a while loop, so I'm going to modify my comment, a while loop. Print. All right, check it out. Which one? We have done here in effectively 2 lines of code, not counting the braces. What took 5 lines of, well, at least 4 lines of code up here. I think once you get used to it, I think once you've typed a for loop more than once or twice, you're going to think, wow, this is really cool. Why? Because it puts the initialization the condition, and the update all in one place. Very easy to tell what it's doing. Here, you know, this update might have been after 500 lines of code. And I wouldn't know, you know, whether we're updating it by 10, by 20, by 1, or whatever, unless I scroll down there and check, or whether the programmer before me had actually, you know, put in a good comment about it. Whereas here, we know right away, okay, we're adding 10 to y each time. Let's print it. Let's run it. All right, looks like it worked. 10 all the way out to 100, 10 all the way out to 100. So, for loops, in my opinion, are the best loop. One loop to rule them all, and in the darkness bind them, if you like Lord of the Rings. That's, you can count by negatives. You can do y minus equals 1 or y minus equals 10 or whatever. You can make this condition more complex. You could put an or statement in there. You know, while y is less than or equal to 100, and repeat not equal to quit, you know, whatever. So there's nothing you can do with a for loop that you can't do with a while loop, but on the other hand, there's nothing you can't do with a while loop that you can't do with a for loop, and the syntax is better. However, there are some things that lend themselves better to while loops. A while loop should be used if you don't really know how many items you're going to be reading. If you're processing an indefinite series of data, a while loop's a good way to do it. What do I mean by that? What if we're reading a file? We don't know how many lines are in that file. It could be a file that has 1 line, and it could be a file that has 1,000 lines of data. Well, we can't really set the for loop up with a condition that would handle that. That's better suited for a while loop. Now, yeah, you could monkey with the for loop to get it to work. For loops are best when you use them to iterate through a series, when you're counting values. And there's another kind of for loop which will let you count through a list, which is how we did it in Python. We did for x in y, where y was a list, and it gave us every value in it. People call that a for each loop, especially in C#, where you actually have the keyword each. But then when Java borrowed it, became colloquially known as for each as well, and I believe this text calls it that. So the for loop syntax, you have your initialization, followed by a semicolon, a condition, followed by a semicolon, and an update, followed by a semicolon. Need to shrink this one too, don't I? How did I do that?
Can the update draw from something other than what you put there? Can it be like a global number, like an input or something like that?
Yeah, the update could be a function call, a method call to evaluate, you know, but it really needs to be something that would change the conditions somehow. Are you asking if you could stick sc.next in there?
Yeah,
I'm
like, could you
curious.
Ask for like an input, but like if it doesn't do that, then like you default to like a set number or something like that.
Let's see. Let's see. We're going to need a scanner. Scanner sc is equal to new scanner system.in. You ought to be able to put in anything in the update that you could code in anywhere else. Now I don't have the scanner imported yet. I'm going to cheat and let NetBeans do it. Add import. Now, for int y is equal to 0, y is less or not equal to -1, y is equal to sc.next int. Enter a number or -1 to quit. I'm really not liking the way that looks. And it seems to be giving me grief. I wouldn't make this thing too complex, the update here. If you need to do something really complex, it's probably not best suited for a for loop. Sounds more like while loop material. Get rid of that. May still need our scanner, so I'm going to leave that there.
It'd probably be easier to read with the while loop anyways than at that point.
Yeah, yeah. But people do squirrely things with for loops. The longer you look at code, people do really odd stuff. They'll embed like 3 or 4 start commands there. They'll leave this one out entirely, or they'll leave the update out entirely, in which case by the time you're doing that, you're essentially duplicating a while loop. So trace this code with an input value of 3. System.out.print. Enter a whole number. Type it in. For I is equal to 2, I plus equals number, I plus plus, and then multiply by the factorial. We can do that. Let's create our code that does this. Okay, so we do need our scanner. Scanner SC is equal to new scanner, system.in. Add your import as appropriate for it. Java.util.scanner with the lowercase j and the lowercase u. Let's ask them, or let's tell them what we're doing. We're going to calculate the factorial, which is multiplying all the numbers out. Now let's tell them to enter the last digit, enter the upper limit of the factorial. I'm just going to leave it upper limit. So I'm going to read in a variable and I'm going to store it in the variable limit. So int limit is equal to sc.nextInt. And we ought to do some checking, make sure that, but nah, we're just going to go forward. So now we need our counter and we need our accumulator. Our counter is just going to go 1 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our accumulator is going to be the value that, 1 times 2 times 3 times 4 and so on. So let's call the accumulator fact. You could type the whole word, factorial, whatever. And we're going to start it off at 1. Normally in our sum loops, we start it off as 0. But if you do 0 times 1 times 2 times 3 times 4 times 5, what does it equal? That 0 at the beginning, so what does the whole series equal? Come on, guys, don't make me type this. If you have 0 times 1 times 2 times 3, what does that give you? 0. It gives you 0. So that's why we're actually going to start at 1. All right, so while we don't have our counter yet, int counter is equal to 1. So while the counter is less than the limit, factorial times equals the counter, and then counter plus plus. So if I was going to label this the same way that I did the other one, that's the initialization, this is the condition, and this is the update. Now factorials get huge very quickly, so if you type in a number like 1,000 or something, it's probably going to break Java. Let's find out. 100. Well, what do you know? Maybe I should have printed out the factorial at the bottom. I'll do that. System.out.println factorial equals plus factorial. So the upper limit, I want to go to 1,000. The factorial is infinity. To infinity and beyond. Okay, I'm going to type in a smaller number. What's the factorial of 10? 362,000. What's the factorial of 20? 1.2 e to the 17. You can see that factorials get really huge very quickly. 30. 8e to the 30. Keep playing with it and find about the largest upper limit you can use that doesn't set it to infinity. Try 40, 50, 60. Forgot what number causes it to crash. And I'm going to wander around and make sure everybody's doing okay. Sorry guys, I scrolled up too much here. Let me get the code all back on the screen. There we go. Alright, we increased the font size. Don't know if you needed it, but we needed it in here. So, same code, different font. Okay, so my little question to myself was, what's the largest factorial that we can enter, by and large, before it rolls over to being infinity? So,
5 factorial is 1.
pardon me, you got up to 120?
Well, no, it gave you 24.
Okay, so upper limit of 100, does that work? Yeah, e to the 155. How about an upper limit 200, infinity? So it's somewhere between there. I don't really care too much about it. 150?
I think it's 171.
Okay, cool. 170, getting there. 171, e to the 306. What we're doing is we're going to run up against the limit of the maximum that a double can handle. 172, infinity. So it is 171. What if we changed factorial from a double to a long? It's not going to work nearly as well. Upper limit of 100. Factorial 0. What's going on is the long has a much smaller maximum value. Even though they're both 64 bits wide, the long doesn't support exponents, so it can't go e to the 380 or something like that. So let's Google up maximum value of a double. Actually, we can just print it out. Let's do that. I'm going to change that back. I'm going to change long back to a double. But just somewhere down at the bottom after that print, let's system.out.println largest double is, followed by a plus, followed by the word double with a capital D, double, capital D, dot max value. So this is using what's known as a wrapper class. For every primitive data type, int, long, float, double, char, byte, anything, there's an associated wrapper class that gives it extra powers. And the reason for that is that an int or a double or whatever thing is just a pure value. It doesn't have any functions attached to it. But the wrapper class does. So here's a value. We can ask the wrapper class, what's the maximum value you can store in a double? And here we go. It tells us that the largest value is 1.7 exponent 3 to the 8, 308. Effectively a 17 followed by 307 zeros. You can use that information. Like if you're going to let them do a calculation and you want it to, you could check to make sure that it would fit into an int before you cast it to be an int or something like that. You can check to make sure that your data will fit into your data type using something like max value or min value. So going onwards. That's our for loop. Wait. I want you to rewrite this loop right here. You could even just comment it out. So what I'm going to do to comment it out is I highlighted all that text and then I'm doing source, toggle comment. Rewrite that code to use a for loop. And since I labeled the parts, I put initialize here and I put condition here and I put update there. That ought to make it easy. Why? Because the syntax of the for loop is for, and then you put initialization there, semicolon, you put your condition here, and then you put your update here. The only difference is that your condition is not going to have the word while in front of it. So take a stab at that. So here's how we would do it. We have our initialize and our condition and our update. And we also still need our accumulator. So I'm going to declare that down here. Double factorial is equal to 1. And the rest of this stuff we can put in our for loop. Initialize, counter is equal to 1, semicolon. Condition, counter less than limit. And I think I should have made that counter less than or equal to limit. That was a mistake in my code up here. I think one of y'all was trying to tell me that it was coming out to the wrong answer for low values. So, counter is less than or equal to limit. And then lastly, what's our update? Counter plus plus. And I needed to declare it, so int counter equals 1. Counter less than or equal to limit. Counter plus plus. And that's annoyingly long. I'm going to replace all the word counters with I. My rule of thumb is give everything a good variable name, but loop counters it's okay to cheat on and give single letter variable names. And then factorial times equals I, and then print it out underneath that. Hoping you're getting the conclusion that that was a cleaner syntax than the way we did it in the while loop, especially if you scroll back up and compare them to each other. I can't really do that because I set my font so large I can't get them both on the same screen, unless I cut out some of this stuff. I could do that. Let me just delete some stuff. All right, that's the same code as implemented as a while as implemented as a for. Maybe you'll agree that the for loop looks cleaner, and basically in programming, if anything looks cleaner, it means it's easier to understand and maintain. So we all got it now? Need help? Nope, you're raising your thumb. Okay, cool. So loop comparisons. When do you use a for loop? If you have a definite series of numbers, as they word it, if you know prior to the start of the loop how many times you want to repeat the loop. The do loop. If you need to do the repeated thing at least one time. The while loop. All other cases, if you can't use a for loop or a do loop. So I'm going to go and modify my recommendations that I had up here. So we had our 3 loops, counting loops, user query, sentinel values. Then down here I had recommendations for which loop. Where is that? Yeah, loop types. 1. If you have a predetermined series of values, in parentheses, you know in advance how many times you're going to loop. Use a for loop. And then, if the block of code must be executed at least once, that's your do loop. And then use a while loop if it's okay if the block of code is not executed. Or in other words, use if 1 and 2 are not valid. Use while loops in all other cases. If for or do won't work for whatever purposes. Now honestly, like I said, there's nothing you could write with a for loop that you couldn't write with a while, but the syntax could get messy. So if it seems appropriate to use a while loop, please do. But for a predetermined series of numbers, for loop's by far the best. And do loops are also known as do while, just because of the syntax. So, a nested loop. A nested loop is a loop within a loop. So, for example, the way a nested loop works is you have an outer loop and then you have an inner loop. So I'm just going to write something. Outer loop could be a while or anything, and an inner loop could be a while or anything, you know. What happens is it enters the while loop, and then the code inside the inner loop runs over and over and over until the inner loop exits. Then it comes back out, and it repeats with the outer loop. Then it runs the inner loop over and over and over. It finally exits the inner loop, and it comes back out and checks the outer loop condition. So the inner loop repeats. It completes an entire run for every iteration, every click of the outer loop.
So is it infinite then, or is it just until it?
Like if it was like this, while, or for, let's use for loops. For x equals 1 to 10, that's the wrong syntax, right? But anyways, you get the idea. That's basic. For y equals 1 to 10, print y, or print x comma y. I'm going to change these 10s to 3s so that I don't have to type as many numbers in. So, for x is equal to 1 to 3, yeah, great, x is equal to 1. For y is equal to 1 to 3, so the first time it prints something out, it's going to print 1, 1. We're still caught in the inner loop. So, it's going to print out 1, 2. We're still trapped in the inner loop. So it's going to print out 1, 3. Now we have finally escaped the inner loop. You know, if we were to write this better, it would have been y less than or equal to 3 right there. And this would have been x is equal to 1, semicolon, x is less than or equal to 3. And then the x plus plus. Let's make this actually look like good code. Nope, that should be y plus plus. So this is the outer loop. This is the inner. So for every iteration of the outer loop, it has to run the entire inner loop, beginning to end. So with x equal to 1, y is going to count 1, 2, 3. Then it's going to click up x by 1. And so x is now equal to 2. And it has to start all over. Y is equal to 1, 2, 3. So it prints out 2, 1, 2, 2, 2, 3. Then we exit that loop so it can increment x again. X became 3. And so when we print it out, we go back into the inner loop and it prints out 1, 3, 1, 3, 2, 3, 3. So does that make sense? If this is the x column and this is the y column, then it's having to run this entire series before it can come out and check this again.
So once it hits 3, 3, then it's done and it moves on to the rest of the code.
Right, right. It runs 1, 2, 3, and then it prints 2, 1, 2, 3, and then it prints 3, 1, 2, 3, and then finally we're done. We leave the outer loop. We're out of it. So let's do a nested loop, and then we're going to be about done with this chapter. Except our nested loop is going to print a rectangle. And yeah, we could ask the user how many rows and how many columns, but let's just declare them. int rows is equal to 5. I want to make something that's 5 long. And int columns is equal to 10. I want it to be 10 wide. Then I need a variable that's going to count the number of rows. I'm just going to call it r. Int r is equal to 0. R is less than the number of rows. R++. That's my outer loop. And then for int c is equal to 0, c is less than the number of columns, c++. And then system.out.print, not print line, just print an asterisk or something cool. After that inner loop, we're going to do system.out.print line. And now we're done. When we run this, it's going to print something that's 5 rows tall and 10 columns wide. Let's prove it. Make sure I didn't make any errors. All right, there it is. If I browse that up for a minute, it's 5 rows long, it's 10 columns wide. So who can tell me why I used print here rather than print line? Well, we could experiment. Once you get it running, change it to print line and tell me how it behaves. Boxes. All right, there's a J now. For loops and nested loops. I'm not seeing a homework assignment that I want to assign, so this is going to be the homework assignment. Write a for loop that counts the numbers 1 to 25. Write a for loop that counts from 20 to 60 by 5s. And then write a nested loop to print out a rectangle made of capital of 8s. Ask the user for the number of rows and columns. All right, I'll make a Dropbox for that. Those hopefully shouldn't look too hard. We pretty much have already done that in the in-class assignment, except we didn't ask the user for the number of rows and columns. In fact, I'm going to change that to a star. The 8s would look dumb.